Invariants. C++, the basics. The use of exceptions to signal out-of-range access is an example of a function checking its argument and refusing to act because a basic assumption, a precondition, didn't hold. Had we formally specified vector's subscript operator, we would have said something like the index must be in the 0, size, range, and that was in fact what we tested in our operator. Whenever we define a function, we should consider what its preconditions are and if feasible test them. However, operator operates on objects of type vector and nothing it does makes any sense unless the members of vector have reasonable values. In particular, we did say elem points to an array of SZ doubles, but we only said that in a comment. Such a statement of what is assumed to be true for a class is called a class invariant, or simply an invariant. It is the job of a constructor to establish the invariant for its class, so that the member functions can rely on it. And for the member functions to make sure that the invariant holds when they exit. Unfortunately, our vector constructor only partially did its job. It properly initialized the vector members, but it failed to check that the arguments passed to it made sense. Consider vector v minus 27. This is likely to cause chaos. Here is a more appropriate definition. Vector ha vector. Int s. If s less than 0, throw length error. Elem equals new double. S. sz equals s. I use the standard library exception length error to report a non-positive number of elements because some standard library operations use that exception to report problems of this kind. If operator new can't find memory to allocate, it throws a std bad alloc. We can now write void test. Try vector v minus 27. Catch std length error // handle negative size. Catch std bad alloc // handle memory exhaustion. You can define your own classes to be used as exceptions and have them carry arbitrary information from a point where an error is detected to a point where it can be handled. Often, a function has no way of completing its assigned task after an exception is thrown. Then, handling an exception simply means doing some minimal local cleanup and rethrowing the exception. The notion of invariance is central to the design of classes, and preconditions serve a similar role in the design of functions. Invariance helps us to understand precisely what we want. Forces us to be specific, that gives us a better chance of getting our code correct after debugging and testing. The notion of invariance underlies C++'s notions of resource management, supported by constructors and destructors. Thanks for watching. Subscribe, share and like for more.